In course of this video, I will demonstrate how the chemical energy of flammable substances can be turned into movement by using a 4-stroke heat engine. This is done with the help of a small model motor, a Saito FA-40. Firstly, I have to refuel the little tank. 69% of the fuel consists of methanol, 2% of nitromethane, and another important constituent is lubricant. The starting procedure is as follows. The throttle lever is half opened and some fuel is sucked with the carburetor kept shut by my finger. By now the glow plug is connected to a voltage source providing a voltage output of 1.2 volt and the motor is started by a turn of the propeller. As soon as the motor is running, the glow plug can be disconnected from the voltage source. The wire filament is now heated up by the combustion process. The fuel-air mix is ignited by the hot glow plug close to the top dead center, and this exactly timed explosion causes the rotation of the propeller, which is attached to the crankshaft. This glow plug ignition motor operates similar to a diesel engine. The engine displacement is 6.6 cubic centimeters and the power output is approximately 500 watt. The top revolution speed is 12,000 rounds per minute. You can't see how this engine works by watching the outside. I have removed the valve caps to give you a look at the movement of the valves. The movement is too fast for my camera. You just can see some irregular up and down of the rocker arms. To make the functionality accessible, the motor is disassembled. All construction elements are digitized and used to produce an animation. The shape of some construction elements has been simplified, but without affecting the functionality. Let's reassemble the motor in the virtual reality. I will start with the carburetor. At the left side there is the connector for the fuel line and the mixture screw. At the right side you can see the barrel used to control the aeration, which is actuated by the throttle lever, and finally there is the idle screw. The movement of the barrel is guided by a little screw. While the barrel is turned by the throttle lever, it is also moving slightly to the right, respectively to the left. Let's have a look at the functionality of the mixture screw. By turning this needle valve out, the amount of fuel entering the carburetor increases. Turning in decreases the amount of fuel. With the help of the mixture screw, an explosive mix of fuel and air can be adjusted. The fuel spray is evaporating for the most part, resulting in an ignitable gaseous mixture. The flow of air being pulled into the engine is metered by twisting the barrel with the help of the throttle lever. While set to full throttle, the maximum amount of air is entering the carburetor. While lowering the throttle, the transversal section is reduced and fewer air is passing the carburetor. If the pipe is shut completely, the motor stops running. Let's adjust the mixture screw to its optimal position, which is determined at full throttle at these small model motors. Like expected, the idle screw is used to adjust the mixture while the motor is in idle mode, meaning the lowest rotation speed possible. By turning the screw in, fewer fuel is entering the carburetor, so there is a lower fraction of fuel in the mixture. A lean mixture is created. By opening the throttle, the idle screw is moving slightly to the right along with the barrel, by what the fuel valve is opened too. The fraction of fuel is increasing, leading to a more rich mixture. With the help of the idle screw, the concentration of fuel is altered while the throttle is actuated. Fuel and air enter the carburetor, and an explosive mixture of both components is coming out of this device. Let's assemble the crankshaft by now. One gear wheel and a ball bearing are force fitted at this device, and the whole unit is force fitted at a second ball bearing inside of the housing. The propeller is attached to the crankshaft with the help of a screw nut. The crankshaft is actuated by the piston. Both devices are linked by the connection rod. The connection rod is fixed at the crankshaft by the rear cover plate of the crankcase. The piston is covered by the cylinder. Now let's assemble the camshaft. Two cams are force fitted in a certain angle to each other on the axis of this device. A gear wheel is the fourth part of the camshaft. The rotation of the camshaft is actuated by the gear wheel of the crankshaft, and the two cams cause the up and down movement of the pushrods. The pushrods are twisting slightly during their cycles, and if they would slide directly at the cams, deep scratches would be the result. Small cylinders are used to get a large bearing surface at the cams, and so to reduce the abrasion. The whole mechanism is covered by the camshaft housing. The valves are installed at the cylinder head by now. Spring coils are used to keep the valves closed. That is very important for the functionality of the motor. The cylinder head is attached to the cylinder. Now the rocker arms can be fastened. The poppet valves are opened by the camshaft via the rocker arms and the pushrods. The closure procedure is done by the coil springs. There has to be a small gap between the rocker arms and the top of the valve rod, while the camshaft is at the position closed to ensure that the valves are closed properly. This gap is called valve clearance. The adjustment is done with the help of a small screw at one end of the rocker arm. By turning the screw in, the gap becomes smaller. If the screw is turned in completely, the valve is opened even if the pushrod is at the closed position. The other extreme case is a too large gap, making it impossible to open the valve properly. The correct adjustment is very important, and it has to be done while the motor is cold. The Saito engine used here needs a valve clearance of 0.1 mm. The position of the screw is fixed by a nut. The same procedure is done at the exhaust valve. The mechanism is protected from dirt by the valve caps. Now the exhaust manifold is installed. The last construction element at the cylinder head is the glow plug. It is electrically heated during the starting procedure. The fuel-air mix is ignited with the help of this device. The motor is complete as soon as the carburetor is attached to it. Let's start the engine to discover the 4-stroke principle. The first advantage of the virtual motor is the fact that the flow of fuel and gas can be visualized by arrows. Fuel and air are entering the carburetor and the burnt gas is leaving the motor at the exhaust manifold. There is still no more of the functionality to observe. The second advantage is the fact that all parts of the engine, blocking a look at the interior, can be removed. Now we are able to discover the functionality without any obstacles. The operation of the carburetor has already been discussed. Let's have a look at the 4 strokes of the engine now. During operation, the piston is moving up and down. The highest point of movement is called top dead center. The lowest one is called bottom dead center. 1 stroke is the time between those two dead centers. Via the connection rod, the vertical movement of the piston is turned into the rotation of the crankshaft. The crankshaft is rotating 180 degrees during 1 stroke, for which reason 2 strokes are needed for a complete rotation of the crankshaft. Let's start with stroke number 1. The piston is descending from the top dead center while the intake valve is opened. Fuel-air mix coming from the carburetor is entering the cylinder. The intake valve is closing at the bottom dead center and the second stroke starts when the piston is moving upward. While returning to the top dead center, the volume of the gas is reduced. The gas is compressed, hence it is heated up. The composition of the fuel and the compression ratio of the motor have to be tuned in such a way that the heating of the gas leads to an ignition of the gas mixture while the piston is close to the top dead center. At the top dead center, the third stroke starts. The pressure of hot gas is significantly higher than those of cold gas, and so the forces acting on the walls of the containment are higher. Hence, the piston is driven back to the bottom dead center by a higher force than required to compress the fuel-air mixture during stroke number 2. At the bottom dead center, the exhaust valve is opened and the burnt gas is evacuated from the cylinder, while the piston is ascending during the fourth and last stroke of the process. The chemical energy stored in the fuel is released and transformed into thermal energy. Those thermal energy is used to drive the piston down during stroke number 3. That's why this stroke is called power stroke, because kinetic energy is released to drive the crankshaft, which is accelerated during this process. Stroke number 1, intake, number 2, compression, and number 4, exhaust, extract kinetic energy from the rotating crankshaft and all devices connected to it. The rotation of the crankshaft is slowing down. The movement of the valves and the piston has to be tuned correctly to make a 4-stroke engine operate properly. The intake valve has to be opened at the beginning and closed at the end of stroke number 1 to fill the cylinder with explosive gas. The exhaust valve has to be opened at the bottom dead center and it has to be closed at the top dead center of stroke number 4 to evacuate the cylinder from the burnt gas. Both valves have to be closed properly to make the compression of the gas mixture possible. That's ensured by the valve clearance. The valves are actuated by the camshaft, whereas the angle between the two cams is important for the correct timing. Furthermore, the rotation of camshaft and crankshaft has to be synchronized. That's realized by the two gear wheels. There are 24 teeth at the gear wheel of the crankshaft and 48 teeth at those of the camshaft, by what 2 rotations of the crankshaft generate 1 rotation of the camshaft. The correct position of both gear wheels is important, which is why there is a marking at each of them. You can see 2 small triangles at the gear wheels of this virtual motor, which have to be close to each other during the assembling procedure. Let's now have a look at the ventilation of the crankcase. To avoid the loss of oil, the whole motor is sealed. If the piston is ascending, a negative pressure is generated inside of the crankcase, which is why air is entering the housing. While the piston is descending, a positive pressure is generated and air is coming out of the crankcase. This pin is normally connected to the upper side of the tank to be able to contain the oil spray exiting the crankcase with the air. Let's go back to the real world now. You can hear that the transformation of the chemical energy of the fuel into mechanical work doesn't proceed perfectly. There is an audible sound coming out of the exhaust manifold, caused by the hot gas which is not completely expanded during the power stroke. A fraction of the energy is lost that way. I can also feel losses. The motor is getting hot while operating. Furthermore, I can smell the bad efficiency. The combustion is not complete. Carbon dioxide and water are odorless. You can observe the rapid decline of the fuel level, even if the motor is operating with idle speed. While running out of fuel, the end of this video is reached. Thanks for watching.